Hello friends, welcome to Diamond Academy. In the last lecture we have discussed up to question number 4. So we will discuss question number 5 onwards in this particular lecture. So basically we are discussing the problems on the vector identities. So let's start our discussion. So for solving such type of questions, two important vector identities that are required. Okay, so let us go through this. So we have the first vector identity as, let us suppose we have three vectors A, B and C. Okay, so the first important vector identity is A dot B cross C. Okay, so this is equal to A cross B dot C. Okay, and the second one is A cross B cross C. So this is equal to dot product of first and last vector, that is third vector. So A dot C into B minus A dot B into C. Okay, so these two important vector identities are required for solving such type of questions. So let us discuss these questions one by one. Okay, so the first question is question number 5. We have to prove that divergence of A cross B is equal to B dot curl of A minus A dot curl of B. Okay, so let us start our discussion on the questions. Okay, so we have this as P. Okay, so this we have to solve. Let us solve this. So we have this as divergence of A cross B. Okay, so we have the divergence of A cross B. We can write this as del dot A cross B. Okay, so this is basically, let us write down the vector differential operator. So this is I del upon del x plus j del upon del y plus k del upon del z. Okay, so this is the vector differential operator and dot product with this is A cross B. Okay, so we have this as, so this is equal to summation. Let us write down one step further. So this is I dot del upon del x of A cross B plus j dot del upon del y of A cross B plus k dot del upon del z of A cross B. Okay, so this we can write in a summation form. So this is equal to summation I dot del upon del x A cross B. Okay, so basically this is divergence. So we have taken I dot del upon del x. Okay, so this is equal to summation I dot, this is del A upon del x cross B plus A cross del B upon del x. Okay, so this is equal to summation I dot, this is del A upon del x cross B plus summation I dot A cross del B upon del x. Okay, so this we can further simplify. We can reverse the order of A and del B upon del x. Okay, so on reversing this, there will be a minus sign. Okay, so this is equal to summation I dot, this is del A upon del x cross B. Okay, uh, let us reverse this. So this will be minus. This is minus of I dot, this is del B upon del x cross A. Okay, let us use the vector identities. Okay, so the two important vector identities that are required for solving such type of questions are, the first one is A dot B cross C is equal to A cross B dot C. Okay, second one is A cross B cross C. This is equal to A dot C into B minus A dot B into C is A dot B into C minus. Okay, let us use the first one. So we have I dot B cross C, I dot B cross C. So this is equal to summation. Okay, so let us take this as A, this as B, and this as C. Okay, so we have I dot B cross C. This is A dot B cross C. So this is I. So first term is I. Okay, and second term is del A upon del X, and third term is B. Okay, so this will be equal to I cross del A upon del X. Okay, because we have to write first A cross B dot C dot, and this is B vector. So this is B. Okay, this is summation. So this we have written based on the first identity. Okay, minus. Similarly, this is I dot del b upon del x cross a. So this will be I cross. This is summation I cross del b upon del x dot a. Okay. So basically, so now we have this term. So we have this as summation I cross del a upon del x. This is nothing but curl of a, and this is this term I cross del b upon del x. This is nothing but curl of b. Okay, this is curl of b. So we have this as curl of a dot b is equal to curl of a dot b minus curl of b dot. Okay, and this is equal to divergence of, this is del dot a cross b. Okay, so this is del dot a cross b is equal to b dot curl of a, b dot curl of a minus this is a dot curl of b. So this is basically we have to prove. Okay, let us discuss question number 6. Let us discuss question number 6. The 6 we have to prove that curl of a cross b, curl of a cross b is equal to b dot del into a, b dot del into a minus b divergence of a minus a dot del into b plus a divergence of b. Okay, b dot del into a minus b divergence of a minus a dot del into b plus a divergence of b. This we have to prove. Let us solve this. So we have the curl of a cross b. So this is del cross a cross b. Okay, so this we can write as summation I cross del upon del x a cross b. Okay, so this we can write as, this is equal to summation I cross, this is a cross del b upon del x plus del a upon del x cross b. Okay, let us bifurcate this. So this is equal to summation I cross a cross del b upon del x plus summation I cross del a upon del x cross b. Okay, okay, so this we can change the order of this cross product. This is equal to summation I cross a cross del b upon del x minus summation I cross, this is b cross del a upon del x. Okay, so let us use this identity. Okay, so this is equal to summation a dot c. So this is I dot del b upon del x. This is first term and the last term. So this is I dot del b upon del x into a minus I dot a into del b upon del x. Okay, this is summation minus summation. So this is I dot del a upon del x into b minus I dot b into del a upon. Okay, this is whole summation. So this is equal to, this is summation I dot del b upon del x into a minus, let us change this. So this is this we can write as a dot I into del b upon del x. This is summation. Okay, this is minus summation I dot del a upon del x into b minus, this we can change this, I dot b we can write this as b dot I. So let us change this. So this is b dot I into del a upon del x. This will be plus. Okay, and this is summation. This is summation. This is plus. This is minus minus plus. Okay. So let us further simplify this. So we have this as summation I dot del b upon del x into a minus a dot summation I del upon del x into b. Okay, this we can write like this. Okay, a dot, we can take del upon del x inside. Okay, minus, and we can take the summation out. We can take the value of we can take a out as it is independent of the summation. Okay, minus, this is summation I dot del a upon del x into b plus summation b dot I del upon del x to, okay, so this is equal to, this is nothing but divergence of b into a minus, this is a dot del into b minus, this is I dot del a upon del x, this is divergence of a into b, divergence of a into b plus, this is b dot del into a. Okay, and this is equal to curl of a cross b. Let us verify these terms. Okay, so the first term is divergence of b into a, divergence of b into a. Now second term, this is minus of a minus a dot del into b, a dot del into b. Okay, now we have minus of divergence of a into b, divergence of a into b, this is minus of, this is b dot del into a, this is b dot a into b dot del into a. Okay, so this is the last term. All the terms we have received. Okay, so basically the curl of a cross b is given by this particular expression that is being asked in this question number 6. Now let us discuss question number 7. Question number 7, we have proved that gradient of a dot b is equal to b dot del into a plus a dot del into b plus b cross curl of a plus a cross curl of b, a cross curl of b. Okay, let us discuss this. So we have the gradient of a dot b. Okay, so we have the gradient of a dot b. So this we can write as summation I del upon del x. This is basically the vector differential operator, and this is a dot b. So del we can write as summation of I del upon del x. This means this is equal to I del upon del x plus j del upon del y plus k del upon del z. Okay, so this is basically the summation of this is basically the vector differential operator. We can represent this in this form also, summation of I del upon del x. Okay, so let us further simplify this. So this is equal to summation I of a dot del b upon del x plus b dot del a upon, okay. So from the third identity, let us use this third identity. Okay, so this is something like, so this is summation, this we can write as a dot del b upon del x into I plus this is b dot del a upon del x into I, this summation. Okay, let us use this third identity. Okay, let us find this value of a dot b into C. So we can find this here as A dot B into C is equal to A dot C into B minus A cross B cross C. Okay. Okay, so this is something like this one, A dot B into C. So this we can represent as, let us suppose this as A and this as B and this I as C. Okay, so we can represent this term as, so this is equal to, A dot B. So this is equal to A dot C into B. So we have A dot I into del B upon del X minus A cross B cross C. So this is A cross del B upon del X. Sorry, this is A cross, this is A cross del B upon del X cross I. Okay. Okay, so this is summation. Similarly, let us represent this part. So from here we have this as plus. So this is B dot first term and last term. So this is B dot I into del A upon del X minus B cross. This is del A upon del X cross I. Okay, this is summation and this is, so this is equal to A dot I del upon del X into B. This is summation minus, this is A cross. This we can write as plus times of, this is del B upon del X cross I. So this we can reverse. This is summation I, so summation A cross I cross del B upon del X. Okay, similarly this is summation B dot I del upon del X. This is of A. Let us reverse this. So this is summation B cross I cross del A upon. Okay, so now let us further simplify this. So we have this as A dot summation I del upon del X. We can take A out because it is independent of the order of, sorry, independent of summation, and this is B. Okay, plus A cross summation I cross del B upon del X plus, sorry, summation, this is B dot summation I del upon del X. This is A plus B cross summation I cross del A upon del X. Okay, so this is equal to A dot, this is nothing but summation I del upon del X is nothing but vector differential operator del. Similarly, this is curl of B. This is vector differential operator, and this is curl of A. Curl of. So let us write down here. So this is A dot del into B. A dot del into B plus A cross curl of B plus B dot del into A plus B cross. This is B cross curl of A. Okay, so let us verify this. So we have the first term as A dot del into B. So this is A dot del into B. Now we have A cross curl of B. This is A cross curl of B. Now we have B dot del into A. This is B dot del into A. And at last we have B cross curl of A. So this is B cross curl of A. Okay. Now let us discuss question number 8. So we have proved that divergence of gradient of phi is equal to del square phi. Let us discuss question number 8. Okay, let us discuss question number 8. Okay, so we have this as prove that divergence of gradient of phi is equal to del square. Okay, so let us solve this. So we have the divergence of gradient of phi. This is equal to del dot gradient of phi. Okay, so this is something. So we have this as gradient of phi is equal to del phi. So this is equal to I del upon del x. So let us write down vector differential operator I del upon del x plus j del upon del y plus k del upon del z, and this is phi. Okay, so this is equal to I del phi upon del x plus j del phi upon del y plus k del phi upon del z. Okay, this is nothing but gradient of phi. Gradient of phi. So we have, let us take the divergence of, we have to find the divergence of gradient of phi. So let us take the dot product. Del dot gradient of phi. Okay, so this is equal to del upon del x of del phi upon del x plus del upon del y of del phi upon del y plus del upon del z of del phi upon del z. So this is nothing but del square phi upon del x square plus del square phi upon del y square plus del square phi upon del z square. This is nothing but del square phi. Okay, so we have, this is del dot gradient of phi. So we have del dot gradient of phi is equal to del square. Okay, let us discuss question number 9. Prove that curl of gradient of phi is 0. How we can solve this? In the ninth question, we have to prove that curl of gradient of phi is 0. That is 9. Prove that curl of gradient of phi, this is del cross del phi is equal to 0. This we have to find. This is curl of gradient of phi. This is gradient of phi, and curl of gradient of phi is del cross del phi. Okay, so let us find this. So we have the del phi as, so del phi is equal to I del phi upon del x plus j del phi upon del y plus k del phi upon del z. Okay, we have to take the cross product. So del cross del phi is equal to, let us take this in the form of determinant. This is I, j, and this is k, and we have this as del. Okay, so components of the vector differential operator, let us write down. So this is del upon del x, del upon del y, this is del upon del z, and we have the components of del phi. So this is del phi upon del x, this is del phi upon del y, and this is del phi upon del z. Let us expand this. So we have this as, let us take the cross product. So we have I cap. Let us take the cross product. So we have this as del 2 phi upon del y del z minus del 2 upon del z del y, del 2 phi upon del z del y plus j cap. This is del 2 phi upon del z del x minus del z del x minus, this is del 2 phi upon del x del z plus k cap. This is del 2 phi upon del x del y, del 2 phi upon del x del y. This is del 2 phi upon del x del y minus del 2 phi upon del y del x. Okay, so these two terms are basically same. This is same. These two terms are same because here we have taken on assumption. We have taken as, we have assumed that the function phi has continuous second order partial derivative, partial derivative, continuous second order partial derivative. Okay, so these two terms are same, so we have this as 0 I cap plus 0 j cap plus 0 k. This is basically 0 vector. So we have the curl of gradient of I is 0. Now let us discuss question number 10. Question number 10, divergence of curl of A is 0. We have to prove. We have to prove that. Question number 10. Okay, we have to prove that divergence of curl of A is equal to 0. Let us take the A vector as, this is A1 I cap plus A2 j cap plus A3 k cap. Okay, so curl of A, this is equal to, curl of A is del cross A. This is equal to, let us take this in the determinant form. So this is I, this is j, and this is k. So we have del cross A is the curl of A. Del cross A. Let us take the components of first vector, that is vector differential operator. So this is del upon del x, this is del upon del y, and this is del upon del z. And the second vector is A. So we have the components as A1, A2, and A3. Because A vector we have assumed as this one. Okay, so let us expand this. So we have this as I cap. This is del A3 upon del y minus del A2 upon del z plus j cap. This is del A1 upon del z, del A1 upon del z minus del A3 upon del x plus k cap. This is del A2 upon del x, del A2 upon del x minus del A1 upon del y, del A1 upon del y. Okay, so this is our curl of A. So now we have to find the divergence of curl of A. Okay, so del dot curl of A, this is equal to del upon del x of del A3 upon del y minus del A2 upon del z plus partial differentiation with respect to y of this particular term. This is del upon del y of del A1 upon del z minus del A3 upon del x plus del upon del z of, this is del A2 upon del x minus del A1 upon del y. Okay, so let us expand this. So we have this as del 2 A3 upon del x del y minus del 2 A2 upon del x del z plus del 2 A1 upon del y del z minus del 2 A3 upon del y del x plus del 2 A2 upon del z del x minus del 2 A1 upon del z del y. Okay, so we have these two terms are same. Secondly, we have, so this gets cancelled because we have assumed A vector has continuous second order partial derivative. So we have the order of differentiation as immaterial. So let us write down here. We have assumed the vector A has continuous second order partial derivative. So the order of differentiation is immaterial. Order of differentiation is immaterial. Okay, so del 2 A3 upon del x del y. If we write this as del y del x, then this is equal to del 2 A3 upon del y del x. So the order of differentiation is immaterial. Okay, So this is basically del upon del y of del a3 upon del x, and this is basically del upon del x of del a3 upon del y. Okay, so this basically are same. So the order of differentiation is immaterial. पहले del y के रेस्पेक्ट में करो या फिर del x के रेस्पेक्ट में करो, दोनों का क्या है, सेम होगा. Okay, so this gets cancelled. Similarly, del a2 upon del x del z, del a2 upon del z del x, this gets cancelled. This gets cancelled. Del square a1 upon del y del z, so this gets cancelled. So this is equal to 0. So we have the divergence of curl of A as 0. So let us discuss question number 11. Prove that del cross A is equal to del of, this is gradient of del cross del dot A minus del square A. Let us solve this. So we have, let us write down question number 11. Okay, so in 11th question number 11th question we have to find, prove that del cross A, del cross A is equal to del of del dot A minus del square. Okay, so we have, let us, so we have the curl of A as, let us take the vector A as, this is equal to a1 I cap plus a2 j cap plus a3 k cap. Okay, so del cross A vector is equal to I, j and k. This is del upon del x, this is del upon del y, this is del upon del z, and we have this as a1, a2 and a3. Let us expand this. So we have this as I cap, this is del a3 upon del y minus del a2 upon del z plus j cap. This is del a1 upon del a1 upon del z minus del a3 upon del x, del a3 upon del x plus k cap. This is del a2 upon del x, del a2 upon del x minus del a1 upon del y. Okay, del a3 upon del y minus del a2 upon del z plus j. This is del a1 upon del z minus del a3 upon del x plus k cap. This is del a2 upon del x minus del a1 upon del y. Okay, this is del cross A. Now let us take the cross product with, this is del cross A. So this is equal to I, j and k. This is equal to del upon del x, this is del upon del y, this is del upon del z, and this is del a3 upon del y minus del a2 upon del z. This is del a1 upon del z minus del a3 upon del x. Okay, and this is del a2 upon del x minus del a1 upon del y. Okay, let us expand this. So we have, let us take this as, this we can write as summation I. Let us take this term only. Okay, let us take the cross product. So we have this as del upon del y of, this is del a2 upon del x minus del a1 upon del y. Okay, minus del upon del z of, this is del a1 upon del z minus del a3 upon del x. Okay, so let us further simplify this. So we have this as summation I. This is del 2 a2 upon del y del x minus del 2 a1 upon del y square. Okay, and this is minus del 2 a1 upon del z square, this plus del 2 a3 upon del z del x. Okay, this is summation. So this is equal to summation I. This is something like, so this is, let us take del x common. So this is del upon del x of del a2 upon del y. This from here we have plus del a3 upon del z. Okay, and this is minus of minus summation I. This is del square a1 upon del y square plus del square a1 upon del z square. Okay, let us further simplify this. Okay, so we have this as summation I. This is del upon del x. This is del a2 upon del y plus del a3 upon del z. Okay, minus summation I. This is del 2 a1 upon del y square plus del 2 a1 upon del z square. Okay, let us understand like this. So this is one particular expression, and this is one particular expression. Okay, so in this first expression, let us add del 2 a1 upon del x square. Okay, so we have added here. So let us subtract. Let us um, let us subtract del 2 a1 upon del x square. Okay. Okay, so we have added here and we have subtracted here. Let us further simplify this. Okay, so let us further simplify this. So this is equal to summation I. This we can take inside of this. So this is del upon del x of del a1 upon del x plus del a2 upon del y plus del a3 upon del z. Okay, and this we can represent as, this is minus summation I. This is del 2 a1 upon del x square plus del 2 a1 upon del y square plus del 2 a1 upon del z square. Okay, so this is equal to summation I del upon del x is nothing but vector differential operator. This is del times of, and this is nothing but divergence of, this is divergence of a vector. This is del dot a. Okay, because we can represent this as I del upon del x plus j del upon del y plus k del upon del z dot product with a1 I cap plus a2 j cap plus a3. Okay, this we can represent like this. Okay, now for this we have, this we can represent as, this is del square upon del x square plus del square upon del y square del square upon del z square. This is summation uh, a1 times of I. So this is nothing but a vector. Okay, so this is equal to, and this is del square. This is minus of del square, and this is curl of, this is del cross del cross. Okay, so this is basically, this we have to prove. Let us discuss question number 12. Prove that gradient of fu is equal to f dash u gradient of u. How we can solve this? Prove that gradient of fu is equal to, question number 12. Prove that gradient of f of u is equal to f dash u f dash u gradient of u. Okay, so let us solve this. So we have the gradient of fu as this is summation I del upon del x f of u. So this we can represent as summation I del upon del u into fu into del u upon del x. This is del u to del u upon del x. Okay. So this is nothing but this is summation I. This is f dash u. This is del u upon del x. This is equal to f dash u we can take out. This is summation I del upon del x of u. Okay, so this is nothing but the vector differential operator del. This is equal to f dash u into del of u. Okay, this is nothing but gradient of f of u. Okay, this we have to prove, that is gradient of f of u is equal to f dash u gradient of u. Okay, so what is the application of this expression? So let us take f of r as r cube. Okay, so suppose we have to find gradient of f of r. This is nothing but f dash r into del of r. So this is equal to f dash r. From here we have f dash r as 3r square. So this is 3r square into uh, gradient of r is nothing but r vector upon r. Okay, this we have already studied in previous set of lecture. Okay, so if you have not watched those lecture, first watch this for ease of understanding. This is gradient of f of r. Okay, how we can represent this? This is nothing but del r upon del x I cap plus del r upon del y j cap plus del r upon del z k cap. This is nothing but x upon r plus y upon r j cap plus z upon r k cap. This is nothing but r vector upon r. Let us write down one step further. This is x I cap plus y j cap plus z k cap upon r. This is r vector upon r. Okay, this is nothing but del of r. So del of r is equal to r vector upon r. Let us discuss last question, that is question number 13. Let us discuss question number 13. Okay, so we have f as f is equal to x square y I cap plus xz j cap plus 2yz k cap 2yz k cap. Okay, so we have to verify that divergence of curl of f is equal to 0. Divergence of curl of f is equal to this we have to prove. So curl of f is equal to del cross f. This is equal to I j and k. This is del upon del x. This is del upon del y. This is del upon del z. This is curl of f is. So let us write down the components of this. So this is x square y, and this is xz, and this is 2yz. Okay, so this is equal to this is. Let us take the cross multiplication. So this is del upon del y of this one. This is 2z minus this is x plus j cap. This is del upon del z of this one. This is 0 minus this is 0 plus k cap. This is del upon del x of this is z minus this is x. Okay, this is nothing but curl of f. Now we have the divergence of curl of f. Divergence of curl of f. This is nothing but del upon del x of 2z minus x plus del upon del y of 0 minus 0 plus del upon del z of, sorry, this is del upon del y. This is del upon del z of z minus x square. So this is equal to minus 1. This is plus 0 this is plus 1, this is equal to 0, minus 1, and this is plus 1, so this is equal to 0. So we have the divergence of curl of f is 0. So we have discussed up to question number 13. Okay, thank you.